So today we're going to be looking at simplifying fractions. We will first start with a quick recap of equivalent fractions, and then we'll look at fractions in their simplified form, and we'll go further and we'll have a look at a few examples in our exploration section. If you'd like to watch our video on equivalent fractions before watching this one, click somewhere up here. Just a really quick recap. What are equivalent fractions? They are fractions that describe the same amount, but they have different numerators and different denominators. So as an example, the fraction 3/4 is the same as 6/8, which is also the same as 9/12, and it's also the same as 30/40. All of these fractions are equivalent. They all describe the same amount. They all have the same decimal value, but as you can see, they all have different numerators and different denominators. The way we obtain equivalent fractions is by multiplying the numerator and the denominator by the same number. Right? So to get from 3/4 to 6/8, we multiplied 3 by 2 and 4 by 2. Right? To get 9/12, we multiplied 3 by 3 and 4 by 3. And to get 30/40, we multiplied 3 by 10 and 4 by 10. So all of these fractions, they're all equivalent fractions. They're all equal to each other. However, 3/4, we say, is the fraction that's in its simplest form. The reason that it's in its simplest form is because there is no other number that goes into 3 and 4 apart from 1. So when that happens, when the only number that goes into the numerator and denominator exactly, so without leaving a remainder, when that number is 1, when that's the only number that goes into both the top and the bottom, then we say that the fraction is in its simplest form. Is this fraction in its simplest form at the moment? Well, no, right? Because there is a number apart from 1 that does go into 2 and 4, right? That number is 2. 2 can be divided by 2 without a remainder, and 4 can be divided by 2 without a remainder, right? So let's divide both of them by 2 and see what we get. So if I put a cross by that, I'm going to say divide by 2, put a cross by that and say divide by 2. What do I end up with? Well, 2 divided by 2 is 1, and 4 divided by 2 is 2. Right, so in other words, 2/4 in its simplest form is a half, or 1/2. Let's just rub this out. Let's take the fraction 10/20. Okay, so again, this fraction is not in its simplest form. Right? There are several numbers that go into both 10 and 20. 2 goes into both 10 and 20. 5 goes into both 10 and 20, and 10 goes into both 10 and 20. Let me write all of those numbers down. You should always try and pick the largest number that goes into both the numerator and denominator, right? So I'm going to pick 10, and I'm going to divide both my numerator and denominator by 10. I'll show you what to do when you maybe can't think of the largest number that goes into both. So if I start with this, if I divide both by 10, right? 10 divided by 10 is 1, and 20 divided by 10 is 2. So once again, just like the previous example, 10/20 is equivalent to, or is the same as, a half. Right? So in its simplest form, 10/20 is the same as a half. Let's take another example now. Let's take the fraction 24/60. Now, once again, this fraction is not in its simplest form. Right? It's pretty easy to tell. Both the numerator and the denominator are even numbers. So at the very least, 2 goes into both numbers. Right? So let's make a list of the numbers that go into both the numerator and the denominator. So 2 does. 3 goes into both 24 and 60. I'm going to write that down. 4 also goes into 24 and 60. I'll write that down too. As does 6. As does 12. Right? These are all of your factors. Let's say that you didn't know off the top of your head that 12 goes into both 24 and 60. But let's say that you did know that 6 goes into both numbers. Well, what you can do is you can divide both numbers by 6, divide by 6 over here, divide by 6 over here, and let's see what we get. 60 divided by 6 is 10. Don't know why I did the denominator first. And then 24 divided by 6 is 4, right? But ask yourself now, is this fraction in its simplest form? No, because 2 can go into 4 and 10, right? So if I'd have to divide them further. So if I divide that by 2 and that by 2, I now get 2 all over 5. 2 over 5 is in its simplest form now. The only number that goes into both 2 and 5 is 1. But if we just started, if we go back, do the question again. Let's go back to 24 over 60. And this time, remember we said that 12 was the largest number that went into both 24 and 60. If we divided both of them, both the numerator and the denominator, by 12, I wouldn't need to simplify any further. Right, so if I cross that off and put divide by 12, cross that, put divide by 12, right? I do 24 divided by 12, which is 2, and 60 divided by 12, which is 5. Wherever possible, always choose the largest number that goes into both the numerator and the denominator. Right, and to recap, this is now in its simplest form because the only number that goes into both 2 and 5 is 1. So let's have a look at another example, right? So let's take the fraction 12 over 17. Is this fraction in its simplest form? Yes, it is. Because the only number that goes into both 12 and 17 is 1. Another giveaway is that 17 is a prime number, right? So, we can't simplify that fraction anymore. It's in its simplest form. Even though there are other numbers that go into 12, such as 2, 3, 4, 6. We don't have any common factors with 17, right? So 2 doesn't go into 17, 3 doesn't go into 17, 4 doesn't go into 17, 6 doesn't go into 17. As I mentioned, it's a prime number. And so 12 over 17 is in its simplest form. Let's do one final fraction. Let's take the fraction 630 all over 990. We have bigger numbers now in our numerators and denominators. In our numerator and denominator, I should say, sorry. I know that 3 goes into both numbers. How do I know 3 goes into both numbers? Well, to test if a number is divisible by 3, you add up the digits and see if that appears in the 3 times table. So if you do 6 plus 3, you get 9. 9 plus 0, 9. 9 is in the 3 times table. What about if I do 9 plus 9 plus 0? Well, 9 plus 9 is 18. 18 plus 0 is 18. And that also appears in the 3 times table. I also know, using the same rule, that 9 goes into both of these numbers, right? Because we can use the same rule to test if numbers are divisible by 9, right? So again, 6 plus 3 plus 0 is 9. And 9 plus 9 plus 0 is 18, and both numbers appear in the 9 times table. So I can divide both of these by 9. I can see they both end in a 0. Let's divide both by 9 and see what we get. You might want to do a little bit of short division over here, or long division. So 9 goes into 6 0 times. There's a remainder of 6. 9 goes into 63 7 times with no remainder. And 9 goes into 0 times. That's 70. Now if we do 990 divided by 9, so 9 goes into 9 once, 9 goes into 9 once, 9 goes into 0 times. So we have 70 all over 110. Is this in its simplest form now? No, both numbers end in a 0, so at the very least we know that 10 goes into both numbers. So let's now divide both of these by 10. So if I put a cross through that, right, divide by 10, put a cross through that, right, divide by 10. Right, I have 70 divided by 10, which is 7, and 110 divided by 10, which is 11. Is this fraction in its simplest form now? Yes, it is in its simplest form. Both numbers are prime, 7 and 11, they're both prime numbers. Yeah, so there's no other number that goes into both apart from 1. So it's in its simplest form. You could have, at the very start, instead of dividing by 9 by first, if you realized, you could have divided both by 90. And then you would have ended up with 7 over 11 straight away. You wouldn't have had this additional step over here. But like I said in a previous example, if you can't figure out the largest number that goes into both, find another number that does, right? So that you can reduce your numbers, make them smaller, and then figure out other numbers that go into them. Thanks for watching today's video. Click on one of these boxes to watch another video, and don't forget to like and subscribe.